Hi guys, welcome to another Learn Electronics Repair video. I made a video about 2 weeks ago, all you need to know about amplifiers to fix stuff. And it was really popular, a lot of you liked the video. But one of the things that was mentioned a few times in the comments were people saying, hey Rich, can you do a repair video on car amplifiers? And you know what? I've never actually repaired one before. I mean, I've got a good idea how they work. I basically know what they are. They're Class D amplifiers, normally with a switch mode power supply or a boost converter, if you like, DC to DC. But I've never actually picked one up to try and fix it. So, as I like to listen to the suggestions people make, I went down to the car boot sale on Sunday, and I found this. So the guy wanted, he wanted 20 euros, and I wanted to give him 10 euros. And of course, the way this works, it ended up at 15 euros. And he tells me this is actually working. And you know what? On this occasion, I actually hope he's not telling me the truth, because I wanted one that isn't working. So we'll have to have a look and see if it does work or not, and then hopefully if it doesn't work or there's some problem, we can get on and have a look and fix it. So the first thing I'll do with this is let's determine if it's safe to power this up, and then let's see if it is actually functioning or not. So what do we have here? Well, we have two fuses. 20 amp says sub, and 30 amp F and B, front and back, or F and R is it? Front and rear, yeah. We have ground remote and battery. I'm guessing this might be something to do with starting it up, like you put a voltage on there, but I don't really know these things. And then we have, it looks like right and left front, right and left rear, so that's 4 speakers, and a sub. So it's 4 plus 1, if you like. That's what we have. The model is Hertz H535, so I'm sure I can find a user manual. And I'm sure we can have a look to see what we have here and find a way to test it, which I think if I power this from my bench power supply and I don't try to get too much power out of it, I should be able to work out whether it's good or not. Let's start off though with a few things. Let's check the fuses first. Let's look for shorts on the input, and let's have a look for shorts on any or all of the outputs. That might give us some idea of what condition this is actually in. Okay, I'm on ohms range. Let's have a look first if there's any shorts on this. So this is positive and ground. Well, it doesn't read open circuit, which makes me think that at least one of the fuses is okay, and it doesn't read short circuit. I'm pretty sure I can actually test these fuses just by connecting to the top of them, maybe. Well, that one might be open, or I might just not be making a contact. And this one, yeah, I've kind of pushed inside that, so that one's good. Let's just see if we can actually, yeah, both the fuses are okay. So that's a fairly good sign. Do we have any shorts on any of the outputs? So we have one output here. Yeah, that reads about the same. That reads, well, they're all reading about the same, which I think is probably a good sign. And then what do we have? Yeah, that reads similar as well. So, you know, just having a look at it, I don't see any obvious problems. I'll just figure out how to connect it with this REM connection on here, this remote thing. And then let's connect it to the bench power supply. Let's get some speakers and let's see what it's actually doing. We're ready to power this up. I don't have any speakers attached yet. I just want to power the amplifier. It didn't take me many minutes to find out that this remote connection, you just connect it to 12 volts to turn the amplifier on. So I have it connected to my bench power supply, which I've just set to 13 volts, because I know car batteries are a bit more than 12 generally. I know 13 is unlucky for some, but I actually hope this is not working. The guy wasn't being honest. So I've set the current on the bench power supply. If I just short the output, I've set it to 1 amp. So that's like 12 watts of power, 13 watts of power if it's effectively a short in here. So that shouldn't be able to damage anything. So what we'll do is now, I have the actual amplifier connected to it now, and it's drawing no power at all. So I can just take the voltmeter and just check on volts, and let's have it. So we should have 13 volts coming in here. Yeah, and we have 13 volts, so there's power getting to the amplifier. I'm now going to connect the remote connection to the 12 volts. So let's see what it does. I'll just tag my crocodile clip onto that, and it now draws. Okay, it's gone over an amp, but it wasn't a short. So let's turn the power up again. Let's short the power supply. Let's give it a bit more power. I'll give it 3 amps. I mean, this has a maximum of 5. Let's see what it does with that. So again, we'll start the thing. Yeah, it's come on. And now it's drawing, yeah, a bit over an amp in its quiescent state. So it looks like it's actually working, in as much as nothing's gone bang, and it's drawing some power, so it's obviously doing something. I can actually turn the output powers up to 5 amps now, so the worst thing happens if it's short, this will just trip out at 5 amps. So let's now connect some speakers and audio, and let's see. I don't have enough speakers to test all the channels at once, but I can do them 2 at a time. So let's have a go and let's see what it's doing. I think I have another speaker I can probably connect to the sub as well. Right, I've found a 12-inch speaker and just attached this on the sub connection. I can put this down on the floor, I think. So we'll just drop that onto the floor, out the way for now, and that's connected to the sub output. And I have a pair of these, the other one's just over here out of shot, but it is there, connected to the front, left and right. I have no audio input connected at the moment, but let's switch it on. So I've set the power supply to supply up to 5 amps, and let's see, in its quiescent state it shouldn't really do anything. If I'll just turn the, no, I'll leave it on 5 amps. Let's throw a bit of caution to the wind, because you can't see any shorts. So again, I'll just connect the wire, the REM wire, remote wire. Let's see if it powers up with the speakers on. Well, yeah, again, it's powering up, going to a bit over an amp. And I don't hear any sound, any hiss, anything on the speakers. Let's connect an audio input from my mixer, just a stereo input. This has, looking at it, pre-in, left, right, pre-in. So that's quite a few inputs. I'm wondering if this was actually for the sub. But I'll connect an audio to it. In fact, I may just have a quick look at the user manual, connect some audio to it, and then let's see if it really is working. I'm just taking another look actually at this. So this is from my knowledge of running mobile disco and using active crossovers with the system I had with 3 amplifiers. So we have front pass mode. So I've just set it to full. So I think that lets all frequencies go to the front speaker. The rear is, we have an input switch, front or rear. So I'm going to set that to front as well. So I'm assuming it will take the input from the front and come through all 4 speakers. But we'll have to test the rear speakers separately, because I only have 2 speakers plus the sub. Filter on full again. It has high pass, so I'm assuming that means you can effectively stop the low frequencies going through your speakers. And then the sub again has an input for front and rear, so I'm just going to choose front and rear rather than sub in. So that effector I think should come through both speakers plus the large one on the floor. And then there's an option here for band. which I'm guessing is these adjustments here, so you can low pass, high pass. Yeah, you can effectively set which frequencies are going through to the different amplifiers. We'll leave them alone. So it's set onto 4. It's on 5-channel mode. Let's put it on 3-channel mode because I only have 2 speakers plus the sub attached to it. Input set to front, filter to full again, sub input set to front. Yeah, okay. Let's connect some RCA leads and let's see what it does. Well, you know, that's just sodding typical, because it appears that this guy's actually sold me a working amplifier. Let's just put a little bit of something funky there. Let's see. So obviously, we have sound. You can see the current changing on the power supply there. And I have both speakers working. So I have both channels working front, and I have the sub working as well. I can feel that vibrating when I touch the cone on the floor. So at the moment we have 3 good channels. I'll connect the speakers to the other 2 channels and then see if there's a problem with those 2. But so far he sold me a working one. And once again all the channels are working. So it seems this guy was such an honest seller, he sold me a working 4+1 channel amplifier for €15. But there's more we can do. Oh, so that's sod's law, isn't it? €15 for this, and it's working. The guy was honest, yeah. Sodding typical. So we can't repair it, but we can have a look inside it. Let's have a look around this, and I'll explain to you how this actually works if you're not familiar with these. And I will keep my eyes open at the car boot sale, and I'm sure I will be able to find some faulty ones that we can actually repair. But for now, let's familiarise ourselves. Let's get it opened up and let's see what we have here. I have the cover off. So let's have a quick look around this. And the first thing I can tell you, this is not a Class D amplifier, which is what I expected it to be. This is actually Class AB. And if we just look at the overview of this, what we actually have is, we have this area, these coils and so on. This is actually a power supply. Your amplifier, if you're going to generate a significant amount of power, needs relatively high voltage rails to work on. It needs a plus and minus voltage rail, these being Class B amplifiers. So your speaker on each of the 5 channels, one end of the speaker will connect to ground, and the other end of the speaker will connect to the junction of the collector and emitter of the transistors that's driving it. And I'll draw you this out in a minute so you can see what we have here. But taking a look, and I've had a quick poke around it just to familiarise myself a little bit because I've not worked on one of these before. This is the power supply, this area up to here. And I haven't powered it up with the cover off, but I will. And this will be generating a positive and negative supply rail. This, I'm sure, will be part of the circuit controlling the power supply. This little area, if you notice here, we have 6 devices here, okay? And we have 8 devices here. This little area, I haven't taken the covers off, but I know these will be voltage regulators. So we'll have like a main supply rail for the power amplifiers, and we'll have a lower positive and negative supply rail for the preamplifier, this area. And that's what they are going to be, even though I haven't taken the cover off. Then we have, if you look, groups of devices. We have 4 here, we have another 4 here, and another 4 here. And if you look, this is kind of symmetrical. So this block of components, together with these 2 resistors and these 2 transistors, will form an amplifier channel. And we know we have 4 channels plus sub. So we have one group there, 2 transistors, this block is an amplifier channel. We have the same again, 2 transistors, this block is an amplifier channel. That's 2 channels. And again here, the block, 2 resistors, 2 transistors, a 3rd channel, and the 4th channel. Now the subwoofer we know would be more powerful, we should know is going to be the more powerful channel. And here we have the amplifier port again. Notice these driver transistors are bigger. And we have a single channel here, but the single channel has pairs of resistors and pairs of transistors. So in total there's 4 transistors, 4 resistors in the block on this one, and this is going to be the subwoofer. So that's basically what we have. The front end, this is your preamplifier, and part of that is underneath here as well. So all this is preamplifier. This area is going to be running on the lower voltage rail from these 2 regulators. And this area, the 5 channels, is going to be on the voltage rail generated by the power supplies plus and minus. So now we have an overview, and we can just roughly draw that on paper. We can then have a look closer to see how this actually works. Let's start with the power supply. So this chip here is a pulse width modulator. If I take the torch, and I've actually added to see what this is. This chip is a TL494CN, and that is a common pulse width modulator used in power supplies. So we can have a quick look at the data sheet of that, just so we can familiarise ourselves with it. This is the TL494, and as I determined, just being familiar with some of these chips, this is a pulse width modulator. So this is basically controlling the power supply section of the amplifier. Now we have 2 large transformers, and this is going to form a positive and negative symmetrical voltage supply, as I mentioned. You can see here we have 6 devices. These are saying Q 46, 47, 12, 42, 43. These are going to be probably MOSFETs or bipolar transistors. And then the other 2 devices, we can see are diodes. They're double diodes. So we can have a quick look around this. I'm just on diode mode. Let's have a look at these to see if we can figure out what they are. So I see not really a diode junction there, but I do see what looks like a diode junction across there. Let's go the other way. Well, it's not a diode junction, and that looks like a diode junction that way. This is capacitors charging. I can't specifically say from taking these readings if these are going to be bipolar transistors or MOSFETs. And I think I just read 0 because I have to wait for the capacitors to charge up a little bit there. So we can't say exactly what they are, but we can have a quick look to see how they're connected together. This end is going to be the base or the gate, and then probably drain in the middle and source. So do they all connect to each other? Well, those 2 appear to be in parallel. Yeah, those 2 do. So we'll go on to the source. Yeah, and they appear to be. And then we can look at the ones on the other side, which are here, and I think we'll find a similar thing. Yeah. But in actual fact, I don't really think they are all in parallel with each other. I think what we've seen is the low resistance of these inductors between them. I think much more likely that they're in pairs and they're driving the coil. But only really to figure that out would be to take the top of the heatsink off to see what we have. And secondly, you'd probably have to unsolder the devices or this to really see what they are. But they are working, so I wouldn't worry too much. The whole thing is working. Is there a connection from one side to the other? So if I go like emitter or source of this to the other side. Yeah, it looks like all 8 of them are effectively connected in parallel. And I'll go on the other side again from the middle. So these look like all 8 are actually in parallel, but I don't think that's the case. I think because of the low resistances here, that's what we're seeing. We then have a pair of diodes here, and we have a pair of diodes here, and if you notice they're the opposite way round the direction of the diode, and this I'm sure is because one end is a negative supply, the other one is a positive supply. So we can have a look to see how these are connected. If I go to the 2 negative ends, yes, they connect together, and I thought they probably would do. 2 positive ends, yeah, they connect together. I thought they probably would do. And this is almost certainly like a centre tap or ground connection, yeah? So we have that, and on the other side, let's have a look again. So obviously the diodes are the other way around, so I think this is a positive supply. Or it could be each side is a plus and minus. I need to check on some voltages. It could be actually this is a centre tap and we have a plus and minus supply on both sides. That would make some sense. Just get the meter reading where you can see it. And this is how I work on stuff, guys. This is how I figure it out, okay? Yeah, so it's looking to me like these 2 are a positive supply, these 2 are a negative supply. And this, you'd imagine, would be a centre tap or ground. Does that go to ground where the power comes in from the battery? No, it doesn't. So this is kind of like a floating ground for the amplifier. Let me just zoom out and see where that ground actually goes to. We can actually see the whole thing a little bit better now, so it's easier to work on. So as I was commenting, it looks like all 8 of these devices are effectively in parallel with each other, but for the reasons I mentioned, I don't actually think they are. I think this is because of the low resistance of the on the base, yeah, the low resistance of the coils. If the first pin is the base or the gate and they're all in parallel, these would be in parallel as well. So these 2 read a low resistance between them, probably a gate resistor or base resistor. But these don't. Are they like a pair as well? Yeah, they're like a pair as well when we go on to that pin. And let's have a look on the other side. So this would be the gate or base. Reads a low resistance between the 2. Okay. Doesn't connect to the other 2. And those 2 connect together as well. So it's looking very much like 2 of these form a pair. And we have 1 pair, 2 pairs, and they say they're not connected to the other pairs. 3 pairs, 4 pairs. So I'm getting a good idea now of how this is actually connected up, and I think I can probably draw something that looks like this. Let's just look at these diodes down here. So the middle pin, I think on all 4 is connected together, and this appears to be effectively our ground for the amplifier, but is not connected to the ground coming in from the actual battery. Okay, it's a ground for the amplifier, it's not the chassis ground of your car. The 2 negative ends of these, do they go to the 2 negative ends of these? No, they don't, so they're independent basically. And the 2 positive ends of these are connected together, and they don't go to here. So they appear to be independent pairs, one on this power supply and one on this power supply. I still think it's a positive and negative, but the way to find that out is to power this up. And let's have a look at the voltage on these rectifier diodes, and that will actually tell us if we've got 2 power rails or effectively 4 power rails here, or maybe this power supply is running some of the channels and this one's running the other ones. I have it ready to power up, but let me just explain why I think these two are a positive and negative voltage regulator and this forms a power supply. We have, if we go to the common point between all 4 of these rectifier diodes, which we can say is our ground, this one has this one, pin 1, effectively connecting to ground, and this one has the middle pin connected to ground. Now if we look at common sort of positive and negative voltage regulators, you'll find that's actually what you would expect to see. So this is a common fixed voltage regulator series, which are the 7/8 series. They come 7805, 12, 15 and so on, which is effectively the output voltages, the 2 last digits, and they're 1 or 1.5 amp. So if we have a look 7812 data sheet, this is a positive regulator. It doesn't matter which one I pick, and you'll see if I find it that the middle pin is ground, in ground output, and one of our 2 devices has ground on the middle pin. We know that. The complement of this, if you like, is the 7/9 series. So if we go 7912 data sheet, and they come in different voltages, as I said. So if we go to this, a negative regulator, looks the same. Let me find the data sheet. I just didn't click on a very good link there. This is your 7912. And quite interestingly, you will find that they are actually, the pin out is different. Yeah, I'll make it bigger. So here we have common, which is the ground, on pin 1. Or at least that particular type does. I mean, it's showing you 2. But I've got a feeling ours is this one, and that's what I think we actually have here. And we can test that by measuring the voltages on the amplifier. So now let's have a look to see what we have and if our theories are correct, or at least which of our theories are correct. I have this ready to power up now, but I just want to check this ground again to see where we can probe. It does appear that all these diodes, the center pin goes to ground, so let's go from here. Now this being what looks like a class AB amplifier, and again I will draw this to make it clear for you, it would seem likely that the speakers, one end of the speaker goes to the junction of the transistors, the collector and emitter, or 2 emitters if they are NPN and PNP, and the other end probably goes to this ground here, which is not chassis ground. So this is the ground, this is chassis ground, and we have no connection. This is the end of the speakers. Okay, so some of the speakers go to here, so we have a ground point, so we can measure with reference to here. At this point I've realized that these diodes here and these diodes here, A, the center pins are not all connecting to ground, and B, they're not all connecting to each other. Even though it looked that way, that the center pins were all connected to each other, they're not. And that's because it was starting to not make sense to me, and I'm guessing maybe some of you guys have been shouting at the screen for some time. So let me show you how this is connected up, and this also proves what we actually have here in the way of power supply. So we can see straight away the 2 transformers have a center tap, okay, and the center tap of both are connecting to the negative end of the speakers, and also this point is actually fact is our ground. This is our chassis ground, not the negative end of the car battery ground. That's what we actually have, and that's where the ground is. So why did it look like the centre pins of the diodes were all connected to ground? Well, the reason is the low resistance of the transformers. Let me show you. The centre pin of this diode will actually connect to this end of the winding on the transformer, and the centre pin of the other one will actually connect to the other end of the winding on the transformer. That's where they're actually connecting to, and the same will apply on the other end of the PCB where the other diodes are. So this centre pin will be going to here, or the other end of the winding, but the principle is the same. And this centre pin will go to here. Now the point of all this is that these transformers have a very low resistance. So internally, this point effectively is connecting to here by 0 ohms, and the same for the other end of the winding as well. Internally, effectively is connecting to here. So to our ohm meter, all this is 0 ohms, and once again the same will apply to the other transformer. And again from the centre point is effectively connecting to here, and the other end is effectively connecting to here. This is why all the centre points of the diodes looked like they were connecting together and they were connecting to ground, but they're not, because the yellow lines show the AC output coming from the transformer. Now let me show you where the rectified supply comes out of the diodes. The negative end of this one and the negative end of the other one here will form a negative supply rail. This is your minus from this power supply, and the same with the one at the other side of the board. Likewise, the cathode of the diode, this one and this one, are connected together, and this forms a positive supply rail. And the same applies on the other side of the board as I just mentioned. So we have here again a positive supply and a negative supply. The two are independent, but that's what we have, and I hope now you can see why it looked like all those diodes were actually connecting together when they're not. So the centre pin of the diodes, no, it's not ground, it's actually the AC voltage coming from one end of each transformer winding. Now we've set that straight, let's continue. Now let's power the amplifier up and see how well our theory stands up to the facts. Yeah. So let's have a look. So the amplifier is now on. So these diodes first, and this is the ground, I'm sure this is ground. So let's have a look at what we have. So I've put it onto volts range, of course. Okay, volts range. No, it's auto volts range. Okay. This end of the diode has, well, basically 30 volts, 29 volts. So on the other one. So this is your plus, let's call it 30 volt supply. The negative end, is this a minus? Yeah, and that's a minus 30 volt supply. So this power supply, which had been driven by these four devices, is a plus and minus 30 volt supply. So in that case, what's this one? So we'll go again. Let's look on the diodes. Oh, this is minus 48, and this is going to be plus 48. Yeah, and the same on the other one, because they're in pairs, they're parallel. So we have a plus and minus 48 volts and a plus and minus 29, 30 volts. So that's what you actually have. Let's see if these are voltage regulators. So if this is the positive one with the ground to the middle, this will be the output. Yeah, 15 volts plus, and this will be the other one negative. 15 volts minus. So we now have three power supplies, and we can start to figure this out. I'm confident that we will find that the 48 volt supply will go to the subwoofer and it'll probably appear on these output devices, the transistors, plus 48. That's plus 48. Oh, there's another pair here. Minus 48. Minus 48. So we know that these are the subwoofer and they're running from the plus and minus 48 volt supply, which makes sense. That makes sense. That's where most of the power is. And then we can say from that that these will be on the 24 volt plus and minus. Yeah, 29 volts rather. That one, and there's just going to be the minus. Yeah. Okay, so a few voltage measurements later and a little bit of intuition, we can now start to draw this out on paper, what we actually have. Let's draw this out on a piece of paper to make it a bit easier to visualise what we actually have here. So we have 12 volts from the battery as an input, and we also have 0 volts, ground, chassis, whatever you want to call it, ground, okay, and that's what's coming in, and the 12 volt is powering 2 power supplies. So without tracking it out, we may have something like this. We know we have 2 pairs of what are almost certainly MOSFETs, and we know it's basically a DC to DC converter. So it's quite feasible to think we actually have something like this to ground, and there are 2 MOSFETs in each one in parallel. Okay, so we have like so. Can we draw circles around them? Yeah, maybe we can. We have something like that, 4 MOSFETs. We know they're in pairs because you can measure the gate resistance and there's just a small resistance between each pair. So we have something like that. And we can draw this one as well. Why not? Let's just go over without it. We have something like that. And then I suspect this is like a buck regulator. So from the center point, we have the winding of a coil going to ground. Okay, and this then has 2 secondaries on it. No, sorry, 1 secondary on it, but it's center tapped. We have like this going off my bit of paper, and here we have our double diodes. So we have diodes like this and we have diodes like this. Again, it looks like we have 2 in parallel, so we'll have another one across here like so, and we'll have another one in, not in there, we'll have another one across here like so. And this then is our minus 29 volt supply. This is our plus 29 volt supply, and this point is not earth, we'll call it ground, different symbol. Okay, that's that. Obviously across here then we have capacitors, which we could see on the board there was a number of capacitors, so we're going to have capacitors like this giving our voltage supply. So we have one of those. Okay, coming off here then we have another one. I'm really going to try and draw this one better than I just drew the last one. So let's try and draw it a little bit better. Something like that. 2 pairs of MOSFETs again. Another coil. And we have the same sort of arrangement again on the secondary. I'm not sure this is totally correct, but I think it's going to be something similar. The reason being, these I think are the secondary windings. It looks like we have a centre tapped winding, or two windings connected together here. But it also looks like we have a similar arrangement on the primary side, which means that these MOSFETs might not be driving it quite in this way, this configuration, but it's doing something like that. Then from this one, we also have, this is your outputs, your high voltage, we also have from the negative going into I think it's a 7915 or something similar regulator, and this is then connecting to the chassis ground of the thing, and this is then giving you minus 15 volts, and we have another one on here, 7815 positive regulator plus 15 volts chassis ground. That's what we appear to have in the power supply section, and this, I hope you are enjoying this. This is how I basically reverse engineer circuits to work out what is going on with them. So we have a power supply section. We basically know what it does now. We also know, because we checked, that this voltage rail or pair of rails drives the 4 amplifier channels, the speakers front and rear left, front and rear right, and that this one drives the subwoofer amplifier. On further examination, it looks like the plus and minus 15 don't actually derive like this from the plus and minus 48. It seemed a little bit strange when I drew it, because that means A, these are dropping a lot of voltage, which means it would get very hot, and B, that I don't think a 7815 and 7915 can even handle a 48 volt input. What we have here, if you can see, is on this transformer we have this other winding here and here, which is not present on this one. So this is another secondary, and that comes into this circuit, and if you look down here, I'm sure you'll see a couple of rectifier diodes. So it's now looking very much like this circuit. The plus and minus 15 is actually coming from another winding on this transformer. So not like this, but basically with another winding from here on this transformer. Just make a bit of space where we can put it. Okay, that looks good. 7815, 7915 plus 15 volts, minus 15 volts, and the ground pins connected together and connected to chassis ground. I'm happier with that. I think that's much more like it. It's possible there's a centre tap on this, but I don't see it. I'm quite happy with that little scrolling of a power supply now, and I'm hoping you guys like it as well. Everything appears when you know it's there. When you know it's there, it appears, yeah. Centre tap on here to chassis ground, because it makes sense. And if we look at our amplifier, again the power supply, I'm fairly confident you can see it. Here we have the small secondary, the 15 volt. This is one output of it. This is the other output of it. The two large ones are either end of the 48 volt plus and minus winding. This is the center tap, and can you see just coming down here, this one, a separate winding there, and then the thick ones are the main ones. that, as far as I can see, is the center tab for here and here. As I said, this is a case of I kind of knew it must be there. And a bit like when the wife says something's in the fridge, I can't see it. But when she says it's in the fridge, I know she means it, yeah? And when I know it's in the fridge, for definite, it appears, and there it is, it comes out hiding. And I think the same thing happened with this center tab. And I also hope that some of you guys relate to that story about things being in the fridge, but you can't see them. Now we've had a good look at the power supply section of this amplifier, let's have a look at the amplifiers themselves. We know we have 4 channels plus a subwoofer, so in whatever order they are, we have front right, front left, we have rear right, rear left, and we have the subwoofer. And the subwoofer is the larger one, as that is being powered by the higher voltage, the plus or minus 48 from here. And the other ones, because we measured the voltage on the transistors, are being powered from these plus or minus 29. And we can see that. So if we look at these transistors, we have effectively here a pair of transistors with the smaller one in the middle. This will be the driver stage, and these will be the output transistors for one of the amplifiers. And then the same here, 1 driver, 2 transistors. And obviously the same on this side. So this repeats 4 times, and that's really nice because it means that if we have a fault on one of the amplifiers, we have other ones to compare with. But let's have a look to see how these are basically connected. So we can look at the first one. These transistors are always in the order base, collector, emitter, as far as I've ever seen, base, collector, emitter. So the collectors, we know from measuring, one has a plus and one has a minus supply. And there you go, we can do in resistance to the rectifier diodes over here, which are in parallel. So this transistor actually connects to the negative supply, and the collector of the other one is connecting to the positive supply. Yeah. And then the same will repeat. So if we go to the next amplifier stage, this end I'm pretty sure will be the negative end, yeah, and this one will be on the positive end. Okay, so we have that. The 2 emitters, I'm sure, will be connected together. So let's look at the first amplifier. This is emitter, and this is emitter, and they're connected together. And we will find the same on the next one. Okay. Emitter, and these are actually the emitter resistors, by the way. I'm sure these emitters go to these, yeah, low value resistors. Okay, so low that my meter says they are 0. They're actually 1, 0, they're 0.1 of an ohm, so they're all low value resistors. Let's have a quick look at these transistors themselves. So we'll go to the first one, which we know is on the negative supply. I see a junction there with a positive on the base, but not on the other one. So this way around, negative to the base. Because being on the negative supply, you'd expect this to be the PNP transistor. And there we have a junction, and there we have a junction. So that's PNP. And the other one will be NPN. So we put the black on the base on this one. We're seeing the junction there, but we're not seeing anything here. Go the other way around. Positive to the base, and we have the junction. So they go PNP, NPN, and I'm sure again on the next one will do the same. So if so, this will be the NPN. Yeah, and this will be the PNP. And we have 4 of these, so we can add those to the diagram. Now this amplifier on the higher voltage, it's actually the same, it just has 2 PNP transistors in parallel and 2 NPN transistors in parallel. And again, we'll draw it, but we can look at these. I'm pretty sure these are the PNP, junction, junction, yeah, and then these won't read this way the same because these are the NPN, junction, junction, yeah, so we can see what they are. So we can begin to visualize this, yeah, how it's going to look. And we know that these are connected to this supply rail if we find the rectifiers, and these are the PNP transistors, these two. So if we go to the collector of these, and we go to the negative end of the rectifier diodes, which are here, we have a connection. And if we go to the collectors of the other pair, and we go to the positive end of the rectifier diodes, we have a connection. The speakers will actually connect to the junction of the two emitters. So on this pair, in fact all the pairs, if you look at the emitters, they're basically connected. Oh, let's put this away, you can see it. I'm sorry if it went off the shot while I was measuring those. If we look at the emitters of the NPN and PNP pair, you'll see they're connected together. Yeah, and the same on this 4-channel one up here. So if we go to the emitters, they're connected together, and they'll seem to connect to all the emitters. They're actually connecting through these low value resistors. So let's draw this on our piece of paper. Here is how our amplifiers are wired then. So we have 4 the same, and these ones go from the plus 29 volts to the minus 29 volts. And we have 2 transistors, one NPN and one PNP. And the collector of the PNP is going to the minus. We've measured that by measuring the resistance to the rectifiers and also by measuring the voltage on it. And the NPN, likewise, the collector is going to the plus 29. So we have our 2 transistors like so. This is the PNP transistor, like so. The base will be connected to the driver transistor, the one that was in between. And if we like, we could work out by metering around to see exactly how that's connected. But I think the more important thing at the moment is the emitters. We know the emitters connect, they look like they're connecting to each other, but they're actually connecting via the emitter resistors, which I'll draw in here, hoping I've left enough space. And I've left just enough space. So the 2 emitter resistors are connecting together. Now, the speaker is actually going to be connected from here. So this is your speaker output. And the other end is going to go to the chassis ground. That's the center point of the power supplies I was showing you, not the ground of your car. On all the diagrams, the ground of your car I've drawn like that to show the difference. So we have this circuit and we have it 4 times over. And basically, via the driver transistor, as we have an audio wave, we'll have a sine wave. As the wave goes more positive, this transistor turns on and feeds current this way through the speaker coil. So it moves the speaker coil in one direction. And as we reach the negative half cycle, this transistor turns on and the speaker coil moves in the opposite direction. So that's what's effectively moving our speaker coil. When we pass the 0 point, both transistors are off basically, or just very, very slightly conducting. So the speaker coil is sitting in the middle. And that's how the amplifier output stage works. Let's have a quick look at the other one, the subwoofer. And it's very, very similar. We know we have a plus 48 volts, was it? I think, yes. We have a plus 48 volts. And we know we have a minus 48 volts. And again, we know the collectors are connecting to the 2 voltage rails. So in this case, we have same thing again, collector to emitter. We have the PNP transistor, collector, emitter, base, base. Again, the base will go to the driver. I'm just looking, I will show you, but there's one driver chip, again the same as there was on here. Say driver chip, one driver transistor. So these are then connected via the emitter resistors, and you can see them a bit more clearly now because I've drawn the diagram better. And on this one, we then have a second pair, just the same thing again. So we have another one here, the 2 resistors, which I should have drawn in the same place to make this diagram work better. But it's too late now, yeah. It's too late for niceties now. So here's our other transistor, connected like so, and this point and this point are connecting together. Okay, again the base is going to go over to here and it will connect to this one. There may well be a resistor in here. In fact, I'll draw it better. There may well be a resistor. I'll do it on this one. There may well be a resistor in here. I'm sure there would be. And there may also be a resistor in here. Yeah. These ones are the 0.1 ohm resistors we can see. And these ones I would have to measure, but I'm suspecting, just from amplifiers, they might be somewhere in the region of 30 ohms, up to 100 ohms, something like that. Yeah. So that's what we have. NPN2, PNP2. And the whole point of this is that the two share the load. So when the speaker, which is connecting to here, the big subwoofer speaker, and another pen's giving up. Let's see if we can make it to the end of this. Just about. No, we can't. I have a replacement. So we can now put our speaker. Oh, this one does work. Okay. Our big subwoofer in here, connecting to the junction between the rectifier diodes. Yeah. So what happens now, again, on the input via the driver, on the positive half cycle, these two transistors turn on together, passing half the current each, and the total of those two together goes through your speaker in this direction and causes the speaker to move one way. And again, on the negative half cycle, these two turn on together, sharing half the current each, and your speaker coil moves that way. Okay. So that's how the amplifier works. Now we've looked at this, and I'm just OCD me, so I'm not going to draw the circles I missed out. One of my problems. I think you have to be a little bit OCD to do electronics repair. Comments below. Now we know how the amplifier output stages are connected. Let's have a look if we can work out which of the four amplifiers is right, left, front, rear. I've drawn out the connector on the back. So these connections here are actually the ones on this top row, if you like, here. And then these connections are the ones on the bottom row of connectors you can see under there, because it's not easy to get to the other side while I'm measuring. Let's see if we can figure out which amplifier goes where. So we'll go to the first one over here. And does it go? Well, this is a sub, so yeah, it goes down. That one goes to there. So we know that this one is actually front right. And the next one, let's have a look. So we go to the other one of the two emitters. Is that on front left or rear right? Let's have a look. Oh yeah, okay. So we have front right, rear right. And I'm guessing we probably got front left, rear left as well. Let's have a look. So go to this one. There's front left down under here. Yeah. Front left, and then the other one over here is going to be rear left, which is on the top somewhere. Yeah. So that's all our amplifiers, and the last one clearly is going to be the sub. Yeah. Get on it. Yeah. Sub. Now we know how the four amplifiers work, plus the subwoofer. Let's have a look at something a little bit strange. So on the front of the unit there was a switch marked mode, which is set to 3-channel or 5-channel. And you might think, what does this switch do? Does it like just switch off the other 2 channels if you're not using them? Well, that doesn't make a lot of sense, does it really? I mean, if you're not using them, they're not going to draw any power anyway, especially if there's no speakers attached to them. So why do we need a switch there, 3-channel, 5-channel? And the other thing that might seem a little bit strange is on the back. So we have the sub here, these 2 terminals, and then you have right plus and minus and left plus and minus, and 3 channel says it's going from left plus to right minus, so across the 2 amplifiers. Yeah, you can see that there, and you'll see for the left we have the plus minus, and here we have plus minus. So in the middle, these two, one terminal is right plus and the other terminal is left minus. But if I take my test meter, we know the negative end of each amplifier goes to the centre tap of the transformers, the ground. So let's have a look to see what we have here. I'll have to wire the amplifier down to do this, but if I connect now from right plus to left minus, you'll see they're actually connecting to each other, the plus and minus, and the same here. So it seems that on the right channel the positive end of the speakers is going to ground, and on the left channel the negative end is. In fact, they are. We can see, we've measured it. So what's going on here? Why is it like that? Well, the reason it's like that, and the reason we have a plus and minus on the speaker to start off with, because music is AC, yeah, it's alternating. So why do we have a plus and minus? Well, the reason we have a plus and minus on the speaker is so that on the positive half cycle all the speaker cones move in the same direction. So they all move, for example, outwards. All of your speaker cones move outwards, pushing air out. And effectively on the negative half cycle they move backwards, pulling air in, if you like. And this is to ensure that they're all in the same phase, because if they're not, effectively you have one speaker pushing air while the other one is pulling air, if you like. And that effectively means they're counteracting each other in an enclosed environment. So we need them both to push at the same time. That's why we have a plus and minus. And you would think the minus, just by tradition, is connected to ground, but all the pluses could be connected to ground, all the minuses can be connected to here. It would be the same thing. They'd all still be moving in the same direction at the same time for the waveform. But what you could do, and there's no reason why you couldn't do this, is we'll draw the 2 amplifiers so we know we have 2 of them. Okay, we'll put the transistors in. Minus 29 volts, yeah, and plus 29 volts. And I'll just zoom in a bit so we can see it a bit clearer. Okay, so we can see now. We have our transistors both driving the speaker. Okay, we'll put our speaker here to ground the chassis, not the chassis of the car. I'll have to stop calling it chassis. So if you think about this, on the positive half cycle of the music, let's say we want the speaker to move outwards, and by putting the positive end of the speaker to the transistors it moves outwards. Yeah, we could on this amplifier invert the waveform so that the positive half cycle is now negative, so it's the same waveform just upside down. So this part relates to this part. Yeah, I didn't draw them in line, but that's what we have. Now what would happen if we have the speaker the same way around, plus and minus? On the positive half cycle this cone would move this way. Yeah, and if this had the same waveform but the speaker was reversed, yeah, it would move the opposite way because the polarity of the speaker is reversed. But if we turn this waveform upside down, even though the speaker is connected the opposite way round with the positive to ground, the cone still moves the same direction. So by inverting the waveform you can have this speaker connected the opposite way and it will still move in the same direction. I hope you can see that. And this is quite important because this explains what is happening in the 3-channel mode and why they're doing it. So the first thing to realise, in 3-channel mode it's still using all 5 amplifiers. Yeah, It's not switching 2 of them off, it's still using all 5. But what it's now doing is using one to drive the subwoofer, exactly the same, and it's using 2 amplifiers to drive each of your speakers, your 2 speakers. And the way it's doing it is like this. One amplifier, plus 29, minus 29, and another one. And we'll draw it this way around just because it makes the diagram look better. And notice I've missed off the emitter resistors, but it's not relevant to this particular topic. We have it like that. And what the switch does, it actually, as I was just showing you, it inverts the waveform fed into this amplifier compared to this by 180 degrees. It turns it upside down. Now, the reason it turns it upside down is not to make the speaker coil move in the opposite direction to the other one. And it's not, if you were just thinking, so that the music sounds better upside down, or you can play Dancing on the Ceiling by Lionel Richie and not fall off the ceiling because it's upside down, yeah? That's not why they do it. Why they do it is this. On this amplifier, we have the positive half cycle. And this amplifier, at the same time, we have the equivalent negative half cycle. So what happens is, this transistor turns on, and this one is off because it's PNP. On this side, this one turns on because we have the negative half cycle. So we have the opposite corners turning on, yeah? And when this end goes negative and this end goes positive, the opposite things happen. So on the negative half cycle, and let's find a different coloured pen. On the negative half cycle, this transistor turns on, and on the positive half cycle here, this one turns on. So you have opposite corners turning on each half cycle. And your speaker, we connect from here to here. And this is why we can see on the amplifier that in 3-channel mode, this speaker bridges across 2 amplifiers. Yeah? That's why. Why do they do it? Well, let's have a look at the original amplifier and we'll see why. What is the maximum wattage that our amplifier can produce with its plus and 29 volt supply? Well, first of all, we need to know the resistance of the speaker. Let's say we've got a 4 ohm speaker. Yeah? Let's look at the voltages. So this end of the speaker is effectively connected to 0 volts. It's the chassis. And this end of the speaker can either connect to plus 29 volts when this transistor is fully on and this one is off, or it can connect to minus 29 volts when this one is fully on and this one is fully off. So the maximum waveform we have coming out of here on 0 is plus 29 across the speaker, yeah, or minus 29 across the speaker. But the maximum voltage that can appear across our speaker is 29 volts in either direction. But there's no such thing as negative wattage. The wattage dissipated when the current is flowing one way through the resistance, and the wattage dissipated when it's flowing the other way is still wattage. It's not like it gets hot in one direction and cold in the other because it's negative. Yeah, it doesn't work that way. So the maximum wattage here is going to be watts equals voltage times current, and the current depends on the resistor. Current equals voltage divided by resistance. I'm just off the edge of my paper. Okay, so let's work this one out first. So the current is 29 divided by 4, and if I just take my calculator we can work this out. Okay, so 29 divided by 4, 7.25 amps. So 7.25 amps, yeah? The wattage is 7.25 times the voltage, current times voltage. So it's 7.25 times 29 equals 210 watts. That's not the actual wattage you'll get out of the amplifier, because the amplifier is actually driving AC, and this calculation is based on the maximum DC current, which only occurs at the very peak. So there's a formula called root mean square that you can use to calculate the actual wattage. Well, because I don't like mathematics on the channel, and because we don't really know, and because we don't really need to know what the actual wattage is, that's fine. We can look at the speakers wired in this 3-channel mode using 2 amplifiers per speaker, and we can do the same calculation. So on the positive half cycle, which on this side has been inverted to negative, the maximum voltage that can appear at this end of the speaker is plus 29 volts. But at the same time, this transistor is being switched on. So on the other end of the speaker, you get minus 29 volts. And the same applies on the other half cycle when this pair switch on. The maximum voltage that can now appear across the speaker isn't 29 volts, it's 58 volts. So we can do the same calculation that we did before. Let me just get the calculator. We know that watts equals voltage times current, and we know that current, and we'll put a 4 ohm speaker again, current equals voltage over resistance. So we can work this out, and we can see it's going to be more. Yeah, it's going to be twice as much. So you think you're going to get twice as much wattage. Let's see what does happen. Yeah, so we have 58 volts divided by 4 ohms equals 14.5 amps. So the wattage is V times 14.5, and V is 58. So 14.5 times 58, we've actually got 841 watts now. So we haven't got twice as much wattage, we've got 4 times as much by using the amplifiers as a pair to drive one speaker. And this is called bridge mode. And that's why we have a switch which is saying 3-channel and 5-channel. So it's not switching 2 amplifiers off at all. It's switching the 4 amplifiers to use as 2 pairs of amplifiers in bridge mode, giving you more power into your front speakers. Now we know why they're running this amplifier on 3-channel mode in bridge mode. It's so you can get more power into the front speakers than you could if you were just using 2 amplifiers and switching the other 2 off. This also actually is the reason why we had that strange situation where 2 of the speakers had the positive end connecting to ground and the other 2 had the negative ends connecting to ground. And it's actually done so that this phase switching and this using 2 amplifiers in bridge mode is easier to wire up, because one of the amplifiers is already in the opposite phase to the other one anyway. That's why it's done. So it makes the circuit easier to design to switch between the normal 5 single amplifier speakers and 2 plus 1 subwoofer bridge mode switched amplifier speakers. Now we know about the amplifiers. What's the rest of the circuitry doing that we have here? There's a couple things we haven't looked at. Let's have a look. We have this little circuit here, and there's only one of them on the board. And at first glance, this looks like it might be some sort of power supply. There's some 22 ohm resistors, some capacitors, a few transistors, and 4 diodes that look like they might be wired as a bridge rectifier. If they're a bridge rectifier, you would expect that 2 of the positive ends would connect together, which they do, and 2 negative ends connect together, which they do. So that might be a little bridge rectifier. And I was thinking this might be a power supply, and so I noticed right here this thing which says TH01, and there's only one of these. There isn't one on the other side of the amplifier. and it's tucked under the heatsink, and TH makes me think thermal, yeah, thermometer. So I think this actually is like a thermistor that's monitoring the temperature here, and it's then, I mean, it's right by this, so it doesn't seem unreasonable. That goes into here somehow, and then this either can shut down or reduce the output volume or does something like that. So without going really investigating, unless we have a fault here, I don't think we would need to. I think that's what that actually does. The remainder of the circuit, which is on the front of the amplifier, and this is where we have lots of settings that you can see if I turn it the right way up. So you can probably see that for the setting here, what they call pass mode, allows us to basically set full, high or band. I think full just lets the full frequency range through. This is on the front. High, just the high frequencies, and then band, whatever you set on these three little adjustments here. And I think the whole idea of this basically is so that you can stop all the bass frequencies going into your front speakers, which therefore allows you to increase the volume on the amplifier, more sound without distortion. And then similar over here on the sub, we have settings again, sub in, front, right, left in, and I think this then obviously for the sub allows us just to send all the low frequencies to the sub. So this is an active crossover, and there's similar settings here for the rear speakers, but just has two adjustments. So I'm sure that's what that actually here is, and that we can see connection to here. So here we're going to find basically, I mean, we can see some markings on the board, which is quite nice. Full, high pass, low pass filter, high pass filter. Yeah, so this is kind of like the outputs from the settings on the front. So this must be doing the high pass and low pass. And then underneath, we can see some of these long chips down here. And I'm pretty sure these will be like operational amplifiers, which then effectively drive the 4 channels. So that's what we have. Now, how would we go about fault finding on this if I'd been lucky enough to actually get one that was faulty for €15? Well, the main problems you're likely to have with an amplifier like this are in 2 main areas. One is going to be blown output transistors. With anything electronic, the thing that's doing the most work tends to be the thing that fails. And the other one is the thing that's connected to the outside world tends to be the one that fails, because you don't know what somebody's going to connect to the end of here. Yeah, you don't know why they took wrong sense on voltage in there, or whether they've put a short circuit load or too low impedance load. So these output transistors actually are doing the most work. They've got the highest voltage present, the highest currents present, therefore the most likely to fail. And secondly, they're the most easily damaged because of user error, shall we call it. Yeah. So that is your one main area of problem, is the output devices. And due to that, short circuits in the output devices can cause failures in the drivers, and if you're unlucky, the high voltage from the collector, plus or minus 48 or 29, can find its way down into this circuitry and blow some components here. But the further you go back towards the front end, the less likely the damage is to get. I mean, you might blow the first few devices, but you'd be very unlucky to go through an entire channel destroying all the transistors and the op amps, for example. But that's the main area of problem. The subwoofer is doing the most work, so again, similar situation with that. So amplifier output failure is one of your major problems you would find. The other one is a problem with the power supply. Again, there's 4 MOSFETs, or 2 pairs of MOSFETs on each one. You have the rectifier diodes. Short circuit rectifier diodes could blow the transistors, or a short circuit over here could then blow the power supply. So your second area is a fault in the power supply, A, due to some faulty component in the power supply, effectively destroying other things or just dying, or a short circuit over here, then causing a fault over here. And I would say the second is the most likely of the two. So how would we go about fault finding on this? Well, there's a couple of useful tips I'll give you here. The first one is this: if you have an amplifier like this and you know you have short circuits, or you're reading a short circuit on the 12 volts in, or there's blown devices, the first thing you want to do is separate the power supply section from the amplifier section. And the way to do that, obviously take the PCB out to work on it, but the way to do that is to remove the rectifier diodes. Yeah, so take these rectifier diodes out and take these rectifier diodes out. Yeah, and then you've isolated the load from the supply. You can now work on the power supply to get it running. And although you'll have no output voltage because the rectifiers are not there, what you will find is effectively on the input to the rectifiers, the output from these transformers, when it's running, you'll see pulses, and you'll see high voltage pulses. This one higher than this one. So you can trace through this area of the circuit and know that you're getting drive to where the rectifiers should be. Once you have the power supply section working, don't just put the rectifier diodes back in again. And by the way, when you remove the rectifier diodes, make sure they're all the same type, or make sure you make a note of which one goes where in case there's some difference in them. But now you've got a good working power supply, you need to look at the amplifier side, and this is where you may well have short circuit outputs. The best way to do this is to power the amplifier from a bench power supply. To do that, you're going to need a dual supply, because you know this requires a plus and minus voltage supply, and we know it's the 48 on here and the 29 on here. So something like this, I'll show you, this would do the job quite nicely. Something like this sort of supply. So this one's 0 to 30 volt, 0 to 6 amps. But basically it's a dual one, so you can either use the two supplies independently. You can use them in series, which then gives you a plus and minus 30 reference to ground, or you can use them in parallel to get the 6 amps. So this would give you plus and minus up to 30 volts, up to 3 amps. And that's enough to test amplifiers. If you don't have one like this, but you have a single one, the other way is to use two single bench power supplies and wire them in series again to give you plus and minus supply. So the way you would basically do this, and we could do with two power supplies, two bench power supplies. Plus, minus, this is one. Variable current, variable voltage, so we can limit the current. We take two of these, put another one. Nice little drawing, yeah, for me. This is not bad at all. Minus, plus. And what you do is you connect the plus of one power supply to the minus of the other. And this then goes to the chassis ground of the amplifier. So you've now got, this is 0 volts, so you've now got minus and plus. And you can set whatever voltage you want on the power supply. Now, you don't need to run the amplifier at its full voltage to test it. You can run it at 12 volts or 15 volts or 20 volts plus and minus, something like that. The beauty of this is you can turn the current down. So if you have a short circuit, you can limit it, say, down to 1 amp on its supply, and you can have a look around now to trace where the problem is. Or maybe you've got a problem, it's not short, but you find that one of the transistors, the PNP or NPN, due to a problem with the drive, is being turned on all the time. If you connect that with a full power, you'll probably blow the transistor, you can probably blow the speaker. So this allows you to work on those sort of problems. Now, if you don't have something like this and you want to do this the ghetto way, what you can use is two power packs. So again, you can take a power pack like this, two of these. I mean, this one's a 12 volt, so you can take two of these, take the ends off, and again connect the positive from one to the negative the other, and that is your 0 volts. You then have your plus and minus 12 volts or 19 volts if you use two laptop supplies, and these will be limited. So I mean, if you use one that's maybe 2 amps or 1 amp, as long as it's a decent power supply, if you have a short on the other end, it should just shut down. I mean, I can't guarantee you won't blow the power supply if it's a cheap and nasty one, but normally under short circuit output it just shuts down. You can find that out, by the way, by just shorting the output and see what happens. Yeah, so you can use two of these to power up an amplifier and then work on it without risking damaging the components any more than they're already damaged. A second hint I can give you is for this type of circuit. Now, we know our subwoofer has 2 NPN and 2 PNP transistors, but in some amplifiers, and this is not just car audio, this is, you know, power amplifiers that use in clubs and discos and bars and similar, you may have 4 or more of these transistors in parallel with each other, and you may have some that have blown, and you will not initially know what caused the failure. Was it the incorrect load? Was something wrong with the amplifier? In these cases, what you might find is that one or more of the NPN transistors have survived and the other ones are short or open, or they've exploded, and the same with the PNP. What you can do if repairing is take all of them out. So if there's 4 on each bank, we got the 4 transistors on each bank, is take all of them out, test them, and if you can find one of each that works, or even some similar NPN and PNP power transistor, temporarily you can fit one pair, leave the others out, and you can now power the amplifier up at low volumes, not its full power, but you'll still get a decent amount of sound of it, that's for sure. Connect your speaker and run the output stage with just one pair in there, yeah? When you've fixed the problems, it's working correctly with one pair, you then need to just measure the base and emitter resistors for each of the other ones, just to make sure that they're okay, yeah? And after that, it's safe to put all the rest of the devices in. Again, you can power it from your plus and minus bench power supply, or 2 of the power packs, yeah? And see if it powers up. If it powers up okay, then you know the amplifiers are good. By the time you reach this stage, you know you've got a good amplifier section. You know you've got a good power supply section. You can now put the rectifier diodes back in again. And you're now ready to power the amplifier up. Now, if it's a mains powered amplifier, I would suggest you power it up via a light bulb first, which should come on bright and then go to dim. At that point, you can just feed a low level audio signal in, and the light bulb will pulse a little bit, you know, just very low volume. If it's doing that, switch the light bulb out of circuit, direct power, and run it, yeah? With something like this, I suggest, again, you run the 12 volts coming in off a bench power supply, limit it to a couple of amps, and just see if it's working okay at low volumes, like I was doing. Okay, fine. If it is, turn it up to the full power. My power supplies are 5 amps, and if it's still okay, connect it to the car battery. And if you follow that procedure, it's very unlikely something disastrous is going to happen. You're going to have to start again. It's a shame this wasn't faulty, and I'm going to buy some more of these. Specifically, you're going to find these sort of amplifiers with a similar switch mode power supply, but these are going to be Class D amplifiers, which are quite a different kettle of fish to these Class AB amplifiers. So I'm going to look to find some more we can repair. But in the meantime, I hope you enjoyed that video. There wasn't much work to do, but we certainly had a good look around this. I've shown you the way that I would work out what is what on a circuit like this before I start to repair it. Because if you understand it, you've got a much better chance of fixing it. And now I've shown you how I do that, I'm pretty confident that a lot of you can now do that. You will no longer thinking, oh my God, what is this? You will instantly start breaking down in your mind into chunks, modules of what it is in the modular form, and then start to use your test meter to prove if you're right. And if you're wrong, you'll just change the way you were thinking until you do know what it's all doing. So there's not much left to say on this video now. In fact, all there really is to say is adios amigos, and I'll see you all soon. Ciao for now.